Propeller system. The Diamond DA42 is equipped with two 3-bladed MT constant speed feathering propellers, one for each engine. Now, let's take a deeper look into the propeller system. The DA42 utilizes constant speed propellers, also known as variable pitch propellers. The pitch angle of the blade is controlled by the propeller governor. Once an engine's rotational speed, or RPM, is selected by the pilot, the governor ensures that the RPM is then held constant at different variations of power and airspeed, allowing the engines to operate at optimal performance during different phases of flight. The propeller pitch control system is integrated into the electronic engine control system and automatically controlled by the Electronic Engine Control Unit, or ECU. Each propeller is geared down with a ratio of 1.69 to 1 as the engine turns at a higher RPM than the propeller. Depending on what percentage the pilot chooses to set the engine's power level at, the ECU system will adjust the propeller RPM accordingly. In contrast to most single-engine propeller designs, the constant speed propellers installed on the DA42 are full feathering, counterweighted, oil pressure to decrease pitch designs. In this design, increased oil pressure from the propeller governor drives the blade angle toward low pitch, high RPM, away from feathering. In effect, the only thing that keeps these propellers from feathering is a constant supply of high-pressure engine oil. This is a necessity to enable propeller feathering in the event of a loss of oil pressure or a failure of the propeller governor. Attached to the shank of each propeller blade are counterweights. These counterweights work to oppose the aerodynamic forces of a windmilling propeller and move the blades toward coarse pitch. When turning the blades toward fine pitch, oil from the engine gearbox is pumped to the governor and directed to the propeller hub. Each blade is connected to a piston located inside of the propeller hub. The high pressure from the governor pushes the piston forward and turns the blades. In the event of an engine failure, the DA42's propellers have the ability to feather. Feathering refers to changing the blade angle to reduce drag and minimize the windmilling effect, which can negatively impact the aircraft's performance. Feathering helps maintain better aircraft control and allows for safer single-engine operations. To feather an engine's propeller for the DA42, the power lever must be brought to idle, and the engine master switch must be placed in the off position. All oil pressure is then dumped from the governor, and the counterweights drive the propeller blades toward feather. As centrifugal force acting on the counterweights decays from decreasing RPM, a spring in the propeller hub works to force the blade into the feathered position.